Okay, for everyone. So first, thank you very much for the opportunity to present to the ACLU, and welcome to this presentation from YAML to root, CI/CD pipeline attack, and countermeasures. First, who am I? My name is Hugo Ferreira dos Santos. I'm an offensive security pen tester in Deloitte, France. Also a private teacher in C++ for more than 8 years or 9 years now. Usually what I will do for work will be a lot of programming. I'm also the one developing, managing, and supporting our red teaming and pen testing infrastructures. It's an infrastructure as code, and I'm the one developing it. And I will also lead all our missions that are related to CI/CD workflows or SDLC audit, for instance, everything related to code. And I've been in cybersecurity for a little bit more than 6 years now. To do a quick introduction about the pipeline and why we decided to make a presentation on this subject. First, DevOps. As you know, DevOps is used everywhere in order to develop new solutions, new software, new infrastructures, and it will rely on a set of tools, specific code, specific infrastructure. And it will help you, so DevOps and DevSecOps will help you to have a good collaboration between developers, testers, architects, etc. But if you want to automate everything, so to automate integration, testing, and deployment, in this case, what you will use is the CI/CD pipelines. So agents that would allow you to deploy automatically or by triggering just in one click multiple actions. At the beginning, those pipelines were only available for developers or sysadmins, but nowadays they are more and more used and more available for non-technical persons. For instance, you can have a commercial or marketing team with the ability just by one click to deploy a demo for some clients. You have also the HR team if they want to create new user accounts in order to access some specific networks. And you will also have what we call client sandboxing. So nowadays, lots of companies will make available for their clients a specific repository on GitHub, GitLab, etc., and allow them to deploy some infrastructure if they want. So the company will just manage the backbone, so the infrastructure or the cloud provider, and they will give their clients the opportunity to deploy VMs, to deploy Key Vault. So the attack surface is bigger now than it was before, because before it was only sysadmin. Now, even non-technical persons are able to deploy infrastructure, to deploy new software, and that's what we'll see now. Something important here, we will focus on the pipelines directly. So, let's say the agents and the server that is deploying will not focus on the infrastructure deployed. First here, you will have a classic workflow of all the CI/CD workflow works. The example is for Azure DevOps. So you will have a developer making the code, pushing it to their Azure repos, so Git. You will have the CI part. The CI part will be where will be the integration, so the test of the code. So the code at the end will be deployed as an artifact. After, you will have the CD part, where in the CD part, the pipeline will take this artifact, or will take the code, and will deploy it on the multiple environments. So pre-prod, dev, prod, etc., following a specific workflow. In terms of pipeline, what we will have, we'll have mainly two types of pipeline. The first one is what we call the platform-hosted pipelines. You will have Microsoft-hosted pipeline on Azure DevOps. You have also GitHub Actions on GitHub. You can have on CloudFormation also, on AWS. And those pipelines, the idea is they are provided directly by the platform. So in the case of Azure DevOps, they are provided by Microsoft. they are mainly free. For instance, the Microsoft hosted pipeline you can use up until 1,800 minutes per month, I think, freely. And so, good thing they are free, so in terms of cost, it's perfect. The main issue with this is that because it's provided by Microsoft, if you want to give your infrastructure access to those pipelines, you have to open your network to the API of Microsoft. And we'll see there are some issues with this. We will see it a little bit after. But what we see in companies, it's not, we are not seeing the platform-hosted pipeline a lot, but we're seeing something else called the self-hosted pipelines. Those ones are the ones that are directly hosted inside your infrastructure. So you will manage your own server with your own pipeline agent inside. So you are responsible for the security. The good thing is you can modify and you can fully configure all the security of your pipeline, how many pipelines you will have, so a specific pool in order to be more efficient. You can also choose if you want a long-term one, so a pipeline that will stay forever, and every time someone is trying to deploy something, it will take the pipeline and deploy, or something running as Docker. You can do approximately what you want. Another good thing is that because you are hosting your own server, you can easily fully configure the network configuration. They are already inside your network, so it's easy to include all the internal network rules. But at the same time, there are a lot of issues. First, it's more costly. So what we see a lot in multiple companies is that because it costs a lot, you will have one pipeline that is shared between multiple environments or multiple projects. So if it's the case, if someone succeeds to compromise this pipeline from the dev environment or from the pre-prod environment, it will be able to access the prod environment also. And when it's shared between multiple clients and multiple projects, you will have the same thing. If you are able to compromise the pipeline on dev on project A, you are able to compromise the infrastructure of the prod of project B. So it will be more in terms of cost, or you want to balance everything, or you want to configure, but at least you have the end of this one. Now we will go into the offensive parts, but before some insights, quite important. First, all the scenarios that you will see here are attack scenarios that we saw during our audits. We will use Azure DevOps as a primary example for this one, but the vulnerabilities, except the last one, are applicable to GitHub, GitLab, Bitbucket, CloudFormation, Code Catalyst on AWS when it was existing, because Code Catalyst is now deprecated from 2 weeks ago, I think. In terms of access, we will assume that we have a classic contributor access. So it's what we use in the modern sandboxing and modern repository. Usually you will have the classic contributor access. So the rights to write, read, to deploy, to trigger pipelines automatically via automatic pull request, for instance, or manually by pushing a button. And also, in terms of scenarios, we will have 5 scenarios. We'll go through scenarios with the YAML configuration file. So I don't know if you are all aware of it. The YAML configuration file is a file where you will describe all the steps that the pipeline must go through in order to deploy the code. We'll also see some scenarios with the Terraform files. So Terraform, it's a language used in order to deploy infrastructure. So it's on the Terraform file that you will say, okay, I want a key vault, I want a VM, I want those security, network security rules, etc. For each of those scenarios, you will have different contexts, different prerequisites, and different security restriction. We'll go from the less restrictive one, where you have access to everything, and we saw it during our audits, so sometimes, yes. And also to the most secure, let's say, where you have access to mainly nothing. And finally, a little bit of terminology for Terraform, because it's important for the people that are not used to Terraform. Some keywords. First, providers. Providers are literally a library that you will use on Terraform in order to make an interface with cloud providers. For instance, if you want to create an Azure VM or a Key Vault, you will use Azure RM, which is a provider. You have providers for GCP, for AWS, for F5, Big IP, etc. Every time you are trying to put an external source, an external library, it will be a provider. The resources are the assets that you want to create. So VM, Key Vault, VNet, network security rules, etc. Data sources are a function that will allow you to fetch data about existing resources. So you use resources to create or destroy an asset, and you will use data source to fetch existing data about an existing asset. For instance, you have the name of a VM, and you want to fetch the IP. You will use the data sources. Provisioners, those are specific functions that you will attach to a resource in order to execute code. Something important to note here, there are two provisioners, local exec and remote exec. As I mentioned, it will be attached to a resource, but if you use local exec, it will allow you to run code. We will see it after. But even if you attach local exec to a VM, the idea behind local exec is it will execute code on the pipeline. So even if you create a virtual machine and you attach a local exec to this virtual machine, it will not run code on the virtual machine, it will run code on the pipeline. That's something important to note. The second one is remote exec, and remote exec is used to connect to remote assets, so remote servers, the pipeline, the VMs that you are creating, etc. But the issue with remote exec is asking for credentials, so usually we don't use it. And finally, modules. Modules are literally packaged in Python. So the idea is you have a code that you like, that will create a VNet, VMs, security rules. You want to reuse it, so you create a module about it. So like this, you can reuse this piece of code everywhere. Now, in terms of scenario, for each scenario, you will have this kind of presentation. So the name, remote code execution using what type of files, here the YAML configuration file, and using what kind of attack path. So here the script tags. You will also have the user rights that are prerequisite in order to perform the attack, and also video or pictures showing how we can proceed with this attack. Something important to notice here is that all the rights that are written here, so right access to the repository, the possibility to modify the build configuration, to access a Terraform file, create a service connection, we'll see just after what is a service connection, and to trigger a pipeline, all those rights by default are available if you are a contributor, if you use the classic contributor role. But on this presentation, what you will have is green and red. If it's green, it means that it's something that you need in order to perform this attack. So again, by default on contributor, but you don't need all the rights in order to perform this attack. For this one, you need to have access to the repo, access to the YAML file, and the possibility to modify the build configuration and to trigger a pipeline manually or automatically by pull request, for instance. So here, what we'll have is a YAML file, a classic YAML file, and here a classic Terraform file that will deploy a VM. So we can go to the pipelines. We will see when it's the legit run, you will see it's deploying a VM. It's how it's supposed to work. You don't have any protection, so what you can do is go on the YAML, use the script tag, download from a remote server something called Nabu. Nabu is almost like Nmap. And you can do your remote shell. You can do a remote shell. You go to the remote server. You use Netcat in order to listen for the reverse shell. You use also an HTTP server in order to give Nabu also. You launch a pipeline. a little bit of password, you wait a little bit, and then, okay, on your remote server now you have a reverse shell on the pipeline. So now, just using 2 lines of code, you have access to the pipeline. This is the less restrictive case. We can see during our audits, so it's not unrealistic. Sometimes it's really like this. Something important to note here, as you saw, we use wget, so in order to retrieve Nabu, we use a reverse shell. We can also use SCP if you want, SSH, etc. We were able to do it because on this pipeline you have outbound internet access. It's not always the case, but if you don't have outbound internet access, what you can do is directly write your code. So you can do a cat etc shadow if you want. It's not necessary to have a reverse shell on the pipeline. You can directly run the code and echo and cat and everything. It will be displayed directly on the console of Azure DevOps or on GitOps. On the second one, what we'll have is also with the YAML configuration file, but in this case, we will use official tasks. The idea here is we will have a new kind of security. So something that we saw during the audit is that sometimes security team will implement a static code analysis, blocking the use of all dangerous tags. There is scripts that allow you to run code, as we saw. There is another one called bash. There are a lot of them. So imagine we are blacklisting all of them. We can still do things. What we can do is use official tasks that are provided by the platform. So you will have Azure CLI, for instance. You have the same on GitHub. It's something provided by Microsoft. You will have it on GitHub, on the GitLab, on Azure DevOps, etc. And this task will allow you to run code using the Azure CLI command and using the right of the pipeline. So as you can see here, there is an input Azure subscription asking for a variable. Here it will ask the name of the service connection. So you just have to know the name of the service connection. And what is a service connection? On Azure DevOps, if you want to connect to an external source, you will need credentials in order to connect to this external source. For instance, if you have, as a cloud provider, you have Azure or AWS or GCP, you will need an account, a service account, in order to connect to this cloud provider. So the service connection is the account. So in the service connection that you will create, you will have all the credentials, and Azure DevOps will use this service connection in order to connect to the cloud provider. And so you just have to know the name of the service connection to put it here. Sometimes it's already in a variable, so even if you don't know it, you use a variable, it will work. And you can put your code. So here what we did is we used an official task, so it's legit, and we created a new service principal. Service principal are service accounts in Azure, in Entra ID. So we created a new service principal, and we displayed the secrets. So here you are using directly the rights of the pipeline, because the pipeline has the right to deploy assets on the infrastructure. It means that it has some rights on Azure, on AWS, etc. And we use the rights of the pipeline in order to create a new secret. Like this, you will have your own credentials, so you can use them outside the infrastructure if you want. So you create this, you retrieve the credentials, and then after using Azure CLI from your own laptop, you can do what you want. Something else you can do here, for instance, is to download the TF state. TF state is the state file of Terraform, so it will be the current state of your infrastructure, and it's considered as a sensible file because it contains all the credentials of all the VMs, of all the key vaults, etc. inside your infrastructure that was deployed by Terraform. So it's sensible. But with this, you can download the TF state because you are using the rights of the pipeline without knowing the credentials. Next one that we will see here is using Terraform. So in this case, let's say you don't have access to the YAML because it's a client-side thing. So someone will provide you only the possibility to deploy Terraform code. so to deploy VMs, and you don't have the right to modify the steps of the pipeline. So what you need, what access to the repository, what access to the Terraform files, and the ability to trigger a pipeline, of course. So here, what we'll do in the providers, and we'll add an official provider called external. External is a provider that will allow you to run code directly on the pipeline. So we go on the main file of Terraform, and we add the external one with it's a data source that will allow you to run code. And also, for an example, I will also use a local provisioner. So I create a new resource, it's an empty resource, and I attach the local provisioner in order to execute code also. So fast forward, I go on my pipeline, I run it, I run the Terraform, and then we can see that we have the code execution for the external provider and also the code execution for the local provisioner. And this one works a lot during the audits because there are a lot of things to blacklist, so sometimes there are some holes in the security. Next one, let's add a new security. Something we see a lot is to blacklist all dangerous providers. So in terms of dangerous providers, you have a lot. You have external that will allow you to run code, as we saw. But there are some other a little bit more complicated to use. For instance, local. Local provider will allow you to use something called local files. And local files allow you to create and read files on the pipeline using directly the rights of the pipeline. It's okay. Using directly the rights of the pipeline in order to read any file. So if your pipeline is running as root, you just have the local provider and you will use it to read, for instance, etc shadow. And because you are root, it will work. It will display etc shadow. You don't have to run code. It will directly read the files. We will also blacklist all the provisioners, so local exec, remote exec. There is still a way in this case. What we did for this is, if you go on HashiCorp Terraform website, so HashiCorp is the company that is managing Terraform. If you go on HashiCorp Terraform website, you will have a very good documentation explaining how you can create your own provider and how you can deploy it officially in HashiCorp Terraform in the registry in order to use it after. So that's what we did. We're using the documentation. We made a fork of external because if external was working well, so let's use it. We did a fork. We changed the name to test. Something important to mention here is we did a little mix because the issue with external is that it will wait for an input in the JSON formats and it's boring. So you don't have this issue with the local provisioner that will allow you to put like a who am I end ID and something like this, something you cannot do with external. You have to put it in the JSON format. So what we did is a fork of the external, and in the way it's working with the commands, we took the way of local exec, a little bit of mixed. Then we published it officially in the HashiCorp Terraform registry. Something important to notice here, this registry is still here. We didn't delete it. So if you want to use it during your pen test and everything, you can. It will just run code on the pipeline. So here we have it at the right. We have the Terraform where we will add the provider. So test, Spirit 91 test. And we use the data source in order to run the code on the pipeline. So commands, who am I, and ID. You can also, if you want, here I've let the command keywords, but you can change it. Also, you can put test, test, test everywhere if there is some blacklist of some specific keywords. Just here, for the audit, it was, we could do it like this. But again, if you want to use it, you can. Last scenario, you don't have write access to the repository, you don't have access to the YAML file, you have the possibility to modify the build configuration, so directly the parameters, the configuration parameters of Azure DevOps. You don't have access to the Terraform file, so you cannot modify any files. But you can create a service connection, and you have the ability to trigger a pipeline. Just for the service connection, again, something, let's say it's a feature, something in Azure DevOps a little bit funny is that by default, if you are using the default contributor access, by default you will be a member of endpoint creators, and endpoint creators have the right to create service connection. I don't know why, but using this, if you have the right to create service connection, it's important to know that you can compromise a pipeline without having access to any files. So the idea is, you see, you don't have access to the repository, you go on the pipeline, and you can, this one you can run it, you go on edit, you will see that you cannot edit it because you don't have access to the YAML file. But there is the classic editor. On Azure DevOps, the classic editor cannot be disabled. And you have the possibility to create a service connection. So what we will do is go in the classic editor and change the source. You will say, you will not take as a source Azure DevOps, you will type GitHub. You go on GitHub, you create a public GitHub with just 3 lines of code. In this case, a reverse shell again. You create your own token in order to connect. You go back to Azure DevOps. You add the token. Because you can create another connection, it will work. Service connection, it will work. You make the access with your GitHub. You save. And then, once it's saved, you can run the pipeline. Sorry, I forgot the fast forward here. Netcat to listen for the reverse shell. You wait a little bit and hop. It's okay. You compromise the pipeline without having any access to the files, just by using the possibility to create a service connection with PWD to see where you are and ID to see who you are. So here we saw some scenarios that we can use in order to pen test the pipelines. We looked at YAML and Terraform files. There are other attacks. There are a lot of different attacks. You can also use Ansible, for instance. But what's next for an attacker? So he is able to perform the remote code execution. What will it do? First, he can try to exfiltrate some secrets. So you can send the secret using, if you have an outbound access, using curl, HTTP fetch, what you want, or write it in a disk and get it with SCP, also if you want. If you don't have internet access, again, you can echo or cat the secrets. Something important to notice here, on Azure DevOps, on GitHub, GitLab, CloudFormation, etc., if you try to echo a secret, it will be masked with stars. But one quick tip, it's a feature again, the base 64 of a secret is not a secret. So on all those technologies, if you want to echo a secret, you can echo the base 64. It will work, it will not be masked. So like this, you can retrieve all the credentials that you want. The attacker will also try to abuse the privilege of the pipeline in order to see if he can access all the repos or resources. But he can also do lateral movement in order to, by downloading some tooling, but in order to see if he can abuse other projects, other environments, other clients. So for this, we made a quick experiment. I will go a little bit faster. We made a quick experiment here. What we did is Microsoft is providing every week a JSON file with all the IP address that it will use. So on this, you will have the IP addresses of the gateway, of the Lambda, etc. and as your function. And you will have also the IP addresses that are given to the clients when they ask for an IP address on Azure. You have the same thing on AWS. They are doing it also. So if you have a VM in Azure and you ask for an IP address, your IP address will be inside the JSON file. And this JSON file is publicly available. So what we wanted to do is to try to see what is open on this JSON file, on those IP. So we took all the IP that are given to people. There are 47 million IPs. And we try to scan SSH, WinRM. SSH and WinRM are the two language of two protocols the most commonly used on Ansible. So we wanted to see if there was some infrastructure as code. And we use Nabu with three different methodology with AWS VM, with Azure VM and Azure IP, and with Microsoft Hosted Pipeline directly. So what we saw is that there is a huge gap between AWS and Azure. This one, we think, is due to the fact that first there is a certain trust between Azure and their own infrastructure, and also to the fact that by default, as I mentioned for Microsoft Hosted Pipeline, you will need to open your network to the Microsoft IPs. The issue is those IPs are also on the JSON file, but they can come from two different sources. It's random. There is no documentation saying it will be from there or from there. It's completely random. So one is called Azure DevOps, and you have a list of a lot of ranges, and you are not sure from which range the IP will come. And the other one is that they can take also an IP from the region that Azure DevOps is hosted in. So if you are hosted in France Central, it will take an IP of France Central or an IP of Azure DevOps. It's completely random. So you can launch 2 times in 1 minute difference, and you will see it will be an IP from one or from the other. So if you want to give access to Microsoft Hosted Pipeline on your network, you have to open it to all the network. So what we saw doing in the company is usually when they are using Microsoft Hosted Pipeline, they are opening to all the network directly. So that's why we were able, using Azure DevOps, to see 300,000 applications, IPs open. So it means that 300 applications are opening to all Azure. So you just need to ask one IP and you will be able to attack 300 people, 300 assets. AWS, you will see 70,000. It means that 70,000 IPs are available from open network. So you can SSH, you can WinRM, all those one. As you saw, I didn't speak about GCP because I tried to do the same thing from GCP, but I was banned in 1 hour saying, oh, you are trying to pen test a third party, so you cannot do it. You can do it with Azure, you can do it with GitHub Action, with AWS, but not with GCP, unfortunately. Quick bypass that we found, and we informed Microsoft, and it worked. By default, on Azure, as I mentioned, we did the scan, but by default, you cannot. Azure is blocking all the scans, but it's not you are banned, it's more technical restriction on the pipelines. So what you can do here is we are trying to run the Nabu. Oh, sorry. I don't know what it... Can you please come back? Okay. Sorry. We are trying to run Nabu. So we'll try to run Nabu from the... directly from the pipeline, and also we are trying to run from a reverse shell, so from your server. We run the first one. If you do a quick fast forward, you will see that you are automatically timeout because you cannot do it. If you go on the other one, so what you will do is a reverse shell in order to connect to your remote server. You will have the same thing, so you will see you will be timeout. But there is a way to bypass it because we saw that all the restrictions, again, it's a feature on Microsoft, all the restrictions are only applied to the user shell. So if you want to do sudo with a command, you will run using the user shell with sudo rights, but with the user shell. So what you can do is, here we try the reverse shell. We'll try also the Nabu command. You will see you will be timeout. Okay, so what you can do here is create an interactive shell using Python and PTY. And here, because it's an interactive shell, you can do your sudo su. You are from the root shell, and from the root shell, you can do what you want. You can scan everything. So you can use Microsoft Hosted Pipeline to scan every network. It will be free to you, and it will come from Microsoft IPs and not your IPs. So if you want to attack, you can do what you want. Just for information, we were able to find 2 other things less than 2 weeks ago. on some specific platforms linked to CI/CD pipelines also, but the issue is that they don't have the clearance yet to speak about it. So if we keep in touch, we'll be able to share it with you. So 2 other attacks, pretty funny, those one. It was already disclosed to the companies, but they're saying to wait a little bit before showing. Very quickly, in terms of defensive part, as you can see, there are a lot of things. We've put here all the best practices that you can implement. There are a lot of things. So in terms of secret, isolation and network, hardening, monitoring, access governance. The main issue about this is that it will really depend on your pipeline. There is no universal solution in order to secure to harden your pipeline, because you will not secure in the same way a pipeline that will run only once and one that will run every 5 minutes. Also, it will depend on how your network is working, what kind of tool you need to implement inside in order to connect to your infrastructure. So the idea is to go to your pipeline and to see what it is supposed to do, what the user are intended to do, and you will have to go through all the security points and say, okay, can I put this? Yes, no. If I can put this, can I put it completely or just a part? And you have to make a balance like this in order to make it work, but also to secure it. Again, even for the audit, you cannot use solely a checklist to perform an audit on the pipeline. If you are trying to sell a mission, an audit on your pipelines, and the guy come in with a universal checklist, it's bad. Because they need to adapt to your context. It will really depend on how you are using your pipeline. Finally, key takeaways. During our audits, what we saw is that we had a 100% success rate in the compromise during the audit. Between 1 and 5 days is not to say we are the best, not at all. It's just to say that the security, the maturity security level is very low on the pipelines. So it's pretty easy to compromise them. And mostly, the reason is mostly the agent will run as root administrators, meaning that if an attacker is able to run code, it's okay, he is able to compromise everything. A good thing, we saw a rise of the Docker usage on the task. So Microsoft hosted pipeline are by default using Docker. So all the every time you are running a task, it will be a specific Docker, and then the Docker will be shred. That's a good thing, and we saw it a lot now in the doing OpenTest on self-hosted pipeline. So the good thing about this is you cannot put a persistence, because if you are trying to put a persistence, in any case, Docker will be shred at the end. You can try to escape the Docker, but usually you don't have time for this, so you just try to gather all the secrets that you can. In terms of segmentation, often the network segmentation is very poorly implemented. What we saw during our audit is sometimes you are able to access a pipeline, you install legal laws that will allow you to do pivot on network, and you install it, you scan the network, and you are able to see that there are domain controllers available in the same subnets. So from the pipeline that is accessible from internet, you can directly access with the right of the pipeline the domain controller in an Active Directory. So kind of an issue. Also, the pipeline are shared between environments and projects, so you can use the pipelines in order to pivot to other environments and to the project, and pretty easily. You are in the dev environment, you can go to the prod environment in a few seconds. And last, the lack of effective monitoring. Usually there is no SIEM, EDR, all these things in the pipelines. Because a lot of time when you are running on Docker, putting EDR or putting CM or something like this, it can take time to download it, to implement it. So a lot of companies are saying we want to be efficient, so we don't want to install those kind of tools. Mistake. Because usually your attacks are completely undetected, so you can do what you want. On the vast majority of the platforms, so Azure, AWS, everything, you will have by default some logs. But the issue is you can have logs, but if you don't implement any alerts on those logs, you will have nothing. So usually your attack will be undetected and you can do what you want to. Once you are able to run code on the pipeline, you are literally mainly free. And this is a reference, and thank you very much. I don't know if you have questions.
I'm not sure it's a mistake to not have EDR on your pipeline and your runners. You wrote the slide before, you said the runner should be short-lived. How do you do EDR for a short-lived runner?
That's the issue. Okay, So for the short, what you can do is deploy your pipeline, retrieve the agent of the EDR, install it, and then at the end, run the code, destroy it, but you will not see it. When you are using short-lived pipeline, usually you will not see any EDR. I saw it on some clients, they were doing it. The deployment of each VM took like 1 hour or 2 hours. It was hell, but I saw it. It was not effective at all because the EDR was on audit mode and not on block mode. So I was able to do everything, even to kill the agent. But yeah,
I probably wouldn't recommend this one. And then you said the SIM putting the logs somewhere for threat detection. Are you aware how verbose repo pipeline execution logs are?
Yeah.
The cost is more or less prohibitive.
That's why I mentioned on this that in terms of defensive, there are a lot of things that you can do by default, and you cannot use universal solution by default. Yeah, it's good to have something to retrieve all the logs. Yeah, it's good to have alerts and everything. But if it's a once in a lifetime pipeline, yes, you can do it. If it's a pipeline running every time, yeah, you can do it also, but you have to do it very specifically on some specific. So it really depends on your pipe.
You should see our pipelines. That would be a killer.
Yeah, mine also. Not sure about this.
So thank you very much for the talk. It was super helpful, I think. So on our side, we are actually starting now the adventure into DevOps. I would like it to be DevSecOps, but it's never the case. And we have already set up Azure DevOps in some of our teams, and we are thinking about using GitHub Actions instead. From what I took of the presentation is that these same issues are also happening in GitHub, except for the last one because it was Azure specific. We looked into some of the differences in the features, and I do believe that in GitHub you have more control over the visibility on the code, on the security actions and features. Do you think it's the best decision to choose GitHub instead of Azure DevOps?
Honestly, that's the same. Because in GitHub Actions, it's not that you have more possibility and it's more configurable. In reality, it's not really the case because Azure DevOps is using Git in the background. So it's almost the same. It's just that on GitHub, it's easier to configure because all the configuration, the main configuration are directly available on the UI. And on Azure DevOps, you will have to go per project, per thing. There are the securities, there are the policies, those are different things. So it can be a little bit more tricky to use. Then after the use of GitHub and the use of Azure DevOps CloudFormation, it will really depend on your whole environment. If you are using entirely Azure with Entra ID and all these things, using Azure DevOps is a good thing because you can use Entra ID accounts in order to connect to your Azure DevOps. It's directly linked to Microsoft, so it's easier to use. Why not using Azure DevOps? If you want to stay on a more open source way, you can stay on GitHub, GitLab. It really depends on what kind of environment you are using and what kind of tool your developer are used to. But honestly, it's the same.
Okay, I was really thinking about what you mentioned about the network, which I didn't like at all. It's Microsoft all over again. But let's see. Thank you very much.
You're welcome.
Anyone else?
Thank you for your talk. I just had a question about the persistence. Don't you think it would be possible to actually plan some persistence scripts or malware inside a specific Git branch of a project? Because usually in the actions you can actually modify the Git tree without too much issue.
You can. It works. The issue is when they are using Microsoft or platform-hosted pipeline, you will have you will have a specific time to do your action because after 1 hour, all the Microsoft hosted pipeline are automatically shredded. So you cannot put persistence because it's a Docker also. Even on self-hosted pipeline, you have a limitation of 16 hours, I think, on GitHub, and approximately the same on Azure DevOps. But you can still, if it's a long-term pipeline, you can still put your persistence inside. You can also push on Git, something that we did during our audits. It was not one of the scenarios that we put here, but because you are using the right of the pipeline and not your rights, what you can do is you have access to the dev environment, you deploy to the pipeline, but the pipeline has access to the prod environments because they are shared. So what you will do is, on the pipeline, just use Git, and use Git to push on the main branch, on the other clients or the project, and you can put your persistence as you want like this. But sometimes, because you don't have a lot of time, what you will do is trying to retrieve as much secret as possible, as many secrets as possible, and do a quick lateral propagation, lateral movements, quick lateral movements, and if you have time, you can try to put the persistence in order to see after, or you can proceed, but usually because you have a specific time frame, you will do it quickly. But yeah, you can put persistence if you want.
All right, let's go to the coffee break in a second. I have one housekeeping item first, but let's first say thank you to Hugo. Thanks a lot.